Well, good afternoon, good morning for some people. How are you guys doing? Good.
We're good.
Take it,
Epic.
yes.
Good.
Okay.
Very good.
All right. Today's session, well, it's going to be around a sizing calculations or size Splunk, not Splunk. Sorry. Last. Oh my God, what's wrong with me? Around LogStream sizing calculations. All right. This is for recording. This is November 2021. Community office hours. I am Mo Hassan. I'm staff solution engineer here, or sales engineer, whatever you want to call me. All right. Before we start, so the intention behind the session today, and make this interactive, guys. If you have any questions, don't make it one way, is to get to this point where I will show you the sizing calculator I've been working on. And this is different than the standard one that you might have seen here and there, but the features that's different. I can do a multiple group, chain group from one group to another calculations. I can do multiple destinations out in an automated fashion, if you will. I can do persistent queue calculations. So if someone asks you, well, I need to retain my data for 10 days in a persistent queue, how much disk space do I need? So that calculation is done in the spreadsheet. You can also, this comes all the time. What are the memory requirements? We have basic minimum, but if you, and we will cover those topics in details here, but if you have a higher demand for lookup files, then memory requirements change with that, and we accommodate that in the spreadsheet. I do some, I call it nice to have, non-critical, but EPS. EPS becomes handy. And that question comes up all the time. What is your EPS on the interface? And customers talk about horizontal scaling versus vertical scaling. When you scale vertically, not this way, that way, which means fewer machines, higher specs, you tend to stress out the interface. And we want to stay below the half of the speed. So if your NIC is 1 gig, we want to stay below 500, 600 megabit per second. So we also accommodate that, and we flag that as an error condition if we get to that use case. Also, this is a little neat thing I calculate, which is, again, it really doesn't make a difference anything, but when you size a cluster, there's always an excess capacity, like a few points excess capacity, if you will. And I do show you that. Just to be aware, the objective of the calculations is not to have excess capacity. When I say I need 10 gigs worth of cluster or 1 terabyte of cluster, I want to be able to handle 1 terabyte. There is a buffer that when we do the calculations, we actually have that in the buffer. We say it's going to handle 1 terabyte, but in reality, it might handle 1.3. So, question? Okay. And then finally, deployment costs. Again, nothing got to do with exercise, with the sizing exercise, but it's just good to know. This is how I started my journey. And I came up with this craziest possible scenario you can have the worker nodes connecting to, and just to kind of give you an idea, I have multiple connections from group to group to group, from a sources and a group together, from 2 groups to 1 destination. So I came up with all multiple possible configuration. And I said, if I have this scenario, I've never seen this. I don't think anybody will see this. But if I have this, how can I handle it in my spreadsheet? So this was my goal when I did the calculations or the writing the spreadsheet. This is more realistic scenario for a customer. They have a data center here and multiple data centers in EMEA and APAC, a bunch of gigs ingestion. And this diagram is here to show that we actually can chain the worker groups together, for the obvious benefits, or we can have directly traffic from the agents, if you will, directly to the main thing. So in this case, we have a main data center in the US, and then smaller data centers there, a bunch of Splunk instances there. And so they can actually send to us directly from this worker group to this worker group. That's chaining. We are chaining traffic. And there are certain things in assumption we have to be aware of. Going back to this here, if I want to calculate the requirement for this guy, my input is the sources plus the traffic coming from this group. My output, in this case, my output here is the traffic going to this group and this destination. So we always think of in terms of in, out, no matter what is this in and what is this out. From the worker group perspective or the node perspective, it doesn't matter if it's coming from from a real destination or from another destination called worker group. Just to be aware of that. Is that point clear? I hope it is. Okay. So then again, create a scenario like before. We list all the worker groups and we just list all the in and out for them, and do the calculation. Then we start, figuring out how much. This is just one customer. You know what I mean? Not a real customer, but just kind of exaggeration here, a possible scenario. And then treating each worker group, each data center separately, as separate entity. Then we calculate what you need for this group to handle this much traffic. 5,000 in, 5,000 out. That's 10,000, around 11. I did this off the top of my head. I don't really plug it in the numbers, but I think those are accurate. Something like this here. My requirement was one worker node, but you always want to have redundancy. So we said one, you actually need two, that kind of stuff. The trick here is how to come up with an optimum scenario where the customer buy the bare minimum hardware to get what they need. Because sometimes customers, they have their own specs of hardware, and sometimes it'll be a waste of money. Sometimes it's not, depending on the scenario. So knowing the impact, the pricing, knowing the specs of the hardware gives you the ability to just do the placement properly where it'll be the best outcome for the customer. Okay, again, I'm rushing through this here just to get to the spreadsheet, but let's just review some concepts here. Each worker, so we have a worker node. We have someone calling me. We have a worker node, and worker node is the server. That is our box. Each worker node has worker processes, and we have multiple worker processes. We can control how many worker processes get spawned. So we are a shared nothing architecture. So the worker processes act independently. They don't talk to each other within the box or outside the box. Just think of that concept. Yes, you have servers, worker node, but within that server, there are worker processes, and everything, all the discussion you're going to see here is around in terms of worker processes. Okay, line 2. Data coming from a single connection will be handled by a single worker process. So an incoming connection come in whatever port, and it will a new worker process will be dedicated for this connection, and that's who's going to handle this connection. What does that mean? Which means one in, one out per worker process. It means if I have 1 terabyte, I want to send of syslog, for example, 1 terabyte I want to send to my worker node. It is better to make those 5 connections 200 gig each versus 1 connection 1 terabyte each. The more connections I create, the old term that used to be used in the past called muxing, MUX, where you can spread the load. It's almost like scaling horizontally again within the server itself. So remember, if I'm sending 1 terabyte, it's better if I can, through a load balance or other mechanism, spread those connections among multiple connections. Spread this single connection among multiple connections to get to the total throughput. It becomes really a big factor, especially in a Splunk cloud. Each worker process will maintain and manage its own outputs. So if you have an instance, i.e. a worker node that has 2 worker processes running, and they're both configured to talk to Splunk. So if 2 incoming connections come into this worker process, Splunk will see 2 incoming, then Splunk will see 2 inbound connection at this end. You need to be aware of this, because when people run TCP dump or TCP netstat and TCP in a Splunk side, and they want to know, I sent 3 and how come it's showing 3 and not 1, that kind of stuff. So be aware of the inbound connection for us, and how does it translate to inbound connection for the receiving end, Splunk or otherwise. Okay, last item. When the sizing calculator assumes that 1 physical core, which almost correspond to 2 vCPUs, can handle up to 400 gigs a day. And when we say throughput, which means in and out, obviously. That number is not fixed. In the calculator that I'm going to show you in a second here, this is a configurable item. It is not a configurable item in the interface, in our product. There are certain scenarios where the customer can pump more than 400 gigs a day, depending on the nature of traffic, but those are not very common. The point is, if you have a customer who has a scenario where they can optimize their hardware and they needed to get away from the standard configuration we have, the sizing calculator I have will actually accommodate that. Okay. How much time do we have? We still have time. Memory. We have a standard memory calculations. You'll see it soon here. But extra memory, how do we calculate extra memory? That's based on the number of lookup files and the size of a lookup file. And the formula is here. And I do have that formula in the sizing calculator. So we say, what is the uncompressed file size in megs? We multiply it by a factor of some sort. I will tell you what this factor is. And then we say, how many worker processes do we have in the entire environment? And that gives me how much extra memory do I need. Okay. The factor here is an inverse calculations of the more columns you have in the lookup file, the lower the multiplier. The more columns you have in your input file, in the lookup file, the higher the multiplier. And this came through some work someone did internally in terms of sizing. So they want to measure the impact of number of columns in a lookup file, i.e. the size on the memory requirements. So we have that covered. If a customer know ahead of time that, yes, I need to use 3 lookup files and 1 gig each or 100 gig each, we can accommodate that scenario and say, yeah, we need X amount of memory extra beside the default. This is just FYI. Everything you guys have seen here came from the document, our docs online. Nothing I came up with here except the diagrams. But just in case someone asks you, what's your recommendation for, I live in Azure. Here's some recommendation you can use, If you can add more, if you want to do more, that's fine. But that's where we prefer to stick with those numbers. So you'll get a scenario where I've seen that with customers, they insisted in having very, very high spec hardware. They want to scale horizontally, vertically. I mean, it's waste of money, but doable, So last thing in terms of slides, just be aware of the screen. We can actually have some control over the worker process from the UI. I'm sure there's more control in the conf files, but from the UI perspective, you can actually, this number here, if you guys seen it, it says worker process count, which means how much, it says right here, number of worker processes to create, use negative number to set number of worker relative to CPU. So there are also a minimum number of worker processes you can count, you can have, and then the memory per worker process. These are defaults. The sign is here, do not change. If you change these, it will throw our calculations off in terms of sizing. So it's better to have these here, but we have a way to accommodate different. If you have a customer who will have 96 vCPUs like I had another day, it's probably better to change this because we want to take advantage of the hardware they have. So,
hey Mo, can you can you talk a little bit more about this relative to CPUs with the negative value? Like, can you kind of talk a little bit about what that really means?
Yeah, I think this means I'm going to reserve 2 CPUs for the OS and let you use the rest. So if you have 10 CPUs, I'm taking 2 for the OS, and LogStream, you can use 8 of them.
I got you. Thanks.
I think that's what it means, if I'm not mistaken. But this is recorded, so I'll be proven right and wrong afterwards. Anyway, that's so great. Now, yeah, okay, there we go. Someone just corrected me. So let's jump. Yeah. Go ahead. I was saying.
I was saying that's what it means. You got it exactly right.
All right. So let's talk about the spreadsheet. Can you guys see my screen, or is it too small? No, that's too big. Nobody knows what that means, but anyway. So spreadsheet, I'm going to start explaining the spreadsheet in details here. And so be patient with me and please ask me. I'm trying to accommodate a lot of scenarios, a lot of things that come up over time, questions. Again, the intention here is to automate as much as possible. I don't want someone to pick up the calculator and start doing the numbers. But let's start from top. So anything you see, this column here, it says, no, I don't want to do this. This column here, it says A, I can say A or M. So M means manual, which means I want this to be manual calculation. I will input the data myself, will become yellow. If it's A, it will actually take the data from Other sources, including the previous tab, which is TCO, none of that stuff really applies to this discussion. Or let's say this space, I have options for you. You can actually pick up from a list, or you can just say manual. Yeah, it's really intuitive. But in this case here, we have a customer with 2,500. Let's make this 5,000 daily ingestion. I always use gigs, not terabytes. I'm following Splunk on other people, actually. It's easier to do gigs, even though it's not as intuitive. But so this customer have 5,000 terabytes a day. By the way, we can do 1, 2, 3 years, obviously. You can actually collapse that to 1 year if you wanted to. That little trick here took a long time to code. So let's focus on 1 year, 5N. And we can say, well, I want this automatic calculations. Or I want to say, no, this is going to be 80% reduction. Look, so again, remember the ease of use here. That's what I'm aiming for. I want this to be easy. I don't want you to kind of figure things out. Or I can say, nope, I really have very complicated use case here because I have multiple destinations. Some of them going to S3 and there's 100% copy. The other destination is going to 30% reduction. The fourth destination, 60% reduction. If you have that scenario, what you can do is click on this table and it will do the calculations for you, pick up the entire number, you know what I mean, and drop it here. So that's the output. I thought that was kind of cool, so now you have an option to list multiple destinations, and all you have to do is list multiple destinations and everything will be automatically populated for you. Now I have the aggregate volume in and out. Okay, this is a good number to have. Again, this is per group, per data center. We will handle a scenario. We have multiple data centers in a second here. And then we plug in our specs. Those are the recommended specs, 8 vCPUs. I'm sorry, 8 physical CPUs, which is 16 vCPUs, 3.66 memory, and 32, I think this is 16, and then docks. Then we'll plug in other numbers. By the way, you can actually change those numbers manually, as I said earlier. The pricing here has nothing to do with sizing. It's a good number to have, because if you're trying to figure out the optimum sweet spot between cost and hardware, this becomes a handy metrics to have. Okay. All right. Then PQ, persistent queue. A customer will say, I want X amount of time or retention, So changing the persistent queue or the storage per machine, per worker node will impact these calculations here. How many days and how many hours of persistent queue do I have? If I have 300 gigs per box and I have 4 boxes, I can give you 5 hours of retention. Uncompressed. If it's compressed, it could be 56 hours. So changing the storage, the customer went to 500 gigs disk space per node. All of a sudden, you can retain 9 hours of persistent queue. So again, changing this value will do the calculations for you. If you get questions, how much disk space do I need? That is how you do it. Questions so far? Okay, memory calculations, the same thing. In the previous slide, we discussed how do we calculate memory in case of lookup files. And let me stress here, this is for file-based lookups. This does not apply to API-based, Redis-based, MaxMind. If you doing lookups against those entities, that does not apply here. This is only if you have lookup files on the worker nodes. The metrics of the numbers we collect from you, we say, well, what's the estimated size of a lookup file? And we say the multiplier, and this multiplier you have to figure out based on the previous screen. So let's stick with average, 2.50, that's at 2.50. You can change that multiplier, but I'd like to stick with the average. I'd prefer to go to lower than higher. And then I will ask the question, how many lookup files do you have? So now I have 4 lookup files, 1 meg each. That tells me my memory requirement is fantastic. I'm happy because my memory requirement at this point is 15. I have 32. But look what happened. Let's say if I start using larger files, now I have 300 megs lookup file, and I have 4 of them. I fell below the minimum required. Now my memory requirement dramatically shot up. Dramatically, Now this is a crazy scenario, but you have the option to play with this the way you want it. Now the memory requirement is 96, you know. I mean, so you see what I'm doing here? I'm changing the number of files, the file size, lookup file size, and then I'm comparing this against what I asked for, the shipped or the specs that we initially asked for. Then we said, no, we're wrong in terms of memory. So in a scenario where the customer knows ahead of time, which is very difficult to do sometimes, especially in a POV, and it's hard to tell what's going on. But if there's awareness of how many lookup files they need and how big they are, which is, again, tough to quantify, we can accommodate those actually easily. Questions so far? Okay. Other cool things, not that doesn't really make a huge difference, but I thought it was a nice stats to have. So throughput, I do it per day, I do it per megabit per second, you know what I mean? And I do EPS's calculations. Everything here assumes even distribution of the data. We are assuming the data spread evenly across all the worker nodes. If you have imbalance there, things get thrown off here, but that's the assumption from our case when you do all these calculations. Why do I care about the throughput here? Remember what I said earlier? If a customer has let's just do a big environment. Let's say I want to just increase the so from the worker node requirements, it really heavily impacted by the CPU and the clock speed. So I will just do something crazy. I have like 5 gigahertz machines, and I have something like, I don't know, 128. Look what happened. And this is telling me, now I know I'm falling below the daily ingestion here. No, I'm not. Yeah, I need 13. So this is telling me a machine with 128 physical CPUs and 5 gigahertz clock speed is so fast for me. You know what I mean? I'm risking the fact I might be able to push more traffic than I wanted to. My interface can handle one terabyte a day, 1 gigs a day. You know what I mean? And this is way below the threshold. In a conventional design, by the way, for those who don't know, we always have the capacity of the NIC. So if your NIC is 100 megabit per second, you don't want to push more than 50 or 60. If your NIC is 1 megabit per second, you want to do not more than 500 or 600 gigs. In this case, we are risking the fact we might go outside that because the box can handle it, yet we have accidentally impacted we created a bottleneck basically. And that's what I'm trying to catch. If you have a massive,
There was a question on just add a question. Just we're talking about the even distribution, right? We're saying load balancers are required there. Is that what you're saying as well?
Yeah. So yes. Well, it depends on the source. Sources that have load balancers like syslog, yes, it's required. Sources that Splunk like agent based, you know what I mean? Then you would rely heavily on semi-even distribution because you're not going to get 100% even distribution, you know, unless it's F5.
You have built-in load balancing. So I mean, my point is, you're in order to take advantage of a horizontal scale, you need some sort of mechanism to spread the load among all the nodes. You don't want to try to jam all your data at one node.
Yeah, but the even distribution comment I made is to say, this calculations assume even distribution. Yeah, your comment is valid, but that's not what I was referring to even distribution. You know, it's like if you want those numbers to come to the way we did these calculations here, we assume the even distribution. That's what I was trying to say. But your point is valid. Yeah.
Yeah, people just, I think you got to understand. We ran into this a couple of times. It's important that people got to have a mechanism to spread their load.
Yep.
I second that comment.
It's good to clarify. Thank you, Ed.
Yeah. Okay, I don't know. I'm getting this thing. I'm hitting something not nice supposed to hitting. Anyway, so back to the sizing calculator. So the throughput MPS megabit per second comes handy if you have a scenario where the customer insists on using higher spec CPU boxes more than we need, just to kind of catch that scenario if it happens. EPS is also just nice to have. It's not a big deal, and people always argue what EPS is, but I just assumed, again, over 24 hours, you know, that kind of stuff. Anyway, we did talk about the memory requirement.
Question?
Yeah.
How are you accounting for spikes in the environment? Because it's one thing to say, and we're going to evenly distribute X amount of data over 24 hours, but the spikes are the killer from a capacity standpoint. Is that when you were saying before that you're only calculating 50% utilization of a server?
So the math behind the calculations actually assumes that in the back of the whoever did this math or the came up with this formulas for it, they assume a padding of 10-15%. However, what you should do when I tell my customer is you should always when you say I need 2 worker nodes, that's the minimum requirement. I said add capacity. So you have to add that capacity manually from the minimum required we ask for. That's how you typically.
Okay, because this maybe a note to add, because typically when I talk to customers that they don't want to plan for their average, they want to plan for their worst case, because that's when they need LogStream to work the most, is when things are going the worst.
Yeah, what we can do in that case, instead of sticking with the ingestion numbers, like I'm licensed for 5 gigs, 5 terabytes. Well, give me worst case scenario. Don't tell me what you licensed for. Tell me what you normally see, so I can do it this way too. So we can do it here in the ingestion. And then, or we can just assume I need 2, I'm going to add 1 extra, that kind of stuff. Either way.
And I would advise overdoing it, because that's the 10x when things are falling apart, is when you need the resources the most.
Correct. Yep.
Actually, related to that, since the topic has been brought up, when you say you need 2, for example, does that mean 2 up at the same time? So you really want 3, so that...
Yes. Okay. Yes. That means I need everything we perceive the environment by number of worker processes, not so much of the hardware itself, but the worker processes inside the server is what doing all the work. So all these numbers, assuming the worker processes are running and available for us, meaning hardware is available. Yes. But the capacity question is a good one, by the way. How do I handle spikes, excess capacity? And again, I can just do it by adding a worker node to whatever calculations we have, or probably a better way to say, give me your worst case scenario in terms of ingestion, not so much of what you're paying for. So.
Yeah, that's the thing where when your customers get the most upset is when there's an outage or something and you need it the most and it's fallen over.
Yep. It's these things we have to kind of talk about it. We can actually add an item here, like some kind of option, add 10% capacity extra, 30%. I mean, that's a good idea, actually. Okay, and that's it. And then finally, we have the pricing. And the pricing here, again, not sizing exercise. It makes it, I forgot to mention this one. This is really a cool thing. When I was toying with this thing a few months back, like, I wonder when we do the sizing, how accurate this calculation is based on the assumption. So I came up with it because sometimes, let's say, I don't know, someone's ingesting 1.4 terabytes. And you will say two worker nodes required because each one can handle 1.2, right? So he said, or the customer says 1.3, 1.4, I'm giving him 2. Guess what? I have excess capacity. So it's one way of me just to measure, not that it makes a difference, but one way for me to measure how much extra capacity do you have. Obviously, you want to size this to be a higher number, if possible, but sometimes ingestion or the total output that does not break evenly compared to the number of nodes. So it's a nice thing to have, and that actually might be tap into your other question you asked earlier, how much extra capacity I can handle. This can give you some hint, but really what I would do is just increase the ingestion and just assume the worst case scenario, just like you mentioned. Back to the pricing. Pricing is not sizing related. It comes in the picture when doing ROI, obviously, but also it comes in a picture when if I have a large environment, I want to see what is the sweet spot I said earlier. And for that, I jump to this spreadsheet. Each one of these lines you see here, each one of them is a sizing calculator by itself. Each line. So the earlier diagram I showed you groups, group 1, group 2, group 3, based on a data center, geographical separation, political separation, whatever. And then I do in and out for each group. Now I have my numbers for the groups. I'm going to plug it in and out. Then I have my specs. Hopefully they're the same. You know what I mean? Forget about the cost for now. But then I do the node requirement for this type of ingestion for that group. And I come up with multiple, worker nodes requirements. Anytime my requirements come to 1, I always flag it as black because you really need 1 plus 1. So at a bare minimum, it would work, but not good for resiliency. So in a scenario where customers would ask for, I don't know, let's just kind of make stuff up here. Like this site would have 5 terabyte. This site will have this site will have 20 terabytes. I don't know, just making up stuff, so you see that the memory the node requirement changes. And with that, the cost, because I have certain assumption on the pricing. So now I can play with this the way I want. Now I have a tool to squeeze or change the numbers to adjust them. Now it's like, what happened if I increase the price of the unit, or lower the CPU or something like that? What is the optimum, knowing very well that we'll have extra capacity somewhere. So where do I want to spend this extra capacity, in this data center or that data center? The conventional advice I give everybody, it's always better to scale horizontally with any system, not just LogStream. Horizontal scaling has a lot of advantages versus vertical scaling. Pricing may not be one of them. It could be 3 boxes costing you $10,000 or 2 boxes costing you $2,000. Which one do you want to use? And you can do the same thing with 2 boxes. So this spreadsheet, the way it's laid out, and when each line is the sizing calculator by itself, assumes multiple groups and accommodates the pricing. Just for you to visualize, I don't have any cleaner way of doing this. I played with the machine learning one time, but didn't really play very well with me. But at least you have a visual tool to tell you what is a minimum requirement for this particular ingestion for this site. Questions so far? Comments, concerns? I also use this thing as, beside the sizing exercise, I've always wanted to know what is the sweet spot for anything, you know what I mean? And this accuracy thing I was telling you about earlier here also comes handy, how accurate my prediction is for this particular site. So, any questions? We used to have graphs. Oh, I still have them. Yeah, nice. I have graphs here. The other thing, which is not size and exercise, but I did some little trick here where I can say, I don't know, let's increase the volume sequentially, or let's increase the CPU sequentially. And so I have different CPUs with a fixed volume. Let's not fix this one. You know what I mean? This is still increasing for some reason. And then measure the number of requirements. So at what CPU number do I actually get my ultimate sweet spot? Or at what clock speed I can just fix this thing here, say no to it, and I'm going to change the clock speed, make it sequential, and I will start with, 1 gigahertz. They don't exist, but we start with that. So 1 gigahertz, 2 gigahertz, you machine at those specs, and then it shows me that it's a play tool more than anything else. But the real use for it is having multiple groups and applying each one separately. So now you have a total calculations, which corresponds to the table I showed you earlier. Any questions? No, we have questions in the chat room here. Any chance to convert this partially into Google Sheets? The challenge is, my friend, is this. And this is, by the way, this is part of my TCO ROI calculations. The reason I created this thing, not for the size of, for the exercising, for the sizing exercise, it's really actually to give an automated way when I'm doing TCO with the customer, is like, how do I get your size right away? Because that factors in. Can I separate it? Yes, but there is a bunch of code powering this thing. And this is for the sizing tab. And I don't know how to convert this to Google Sheet language. So, and when you do something like this, automate manual, and when you just remove these things or you populate these things with a formula, this is all powered by the code itself. This is not built-in function that you get out of Excel right away. Or when you lookup tables are built in, but there's some automation and some code powering this thing. So yes, converting this thing might be challenging. Doable, yes, but might be challenging. Any notes on if the leader nodes may need to scale at certain size as well? Who asked that question? Jared, can you explain what are you asking?
Yeah, so for CPU RAM for your leader node, if you have so many users coming in or you have so many worker nodes, is there any calculation on like if the leader node needs to be beefier or, basically if the leader node has to scale horizontally with your work, if your worker node scale vertically, or how many users are logging in, stuff like that.
Yeah. You're basically looking for specs for the master, for the leader node.
Yeah.
I am not aware of any published numbers for it. I can tell you, and it is a lower requirement because it doesn't do much work. It's basically coordinated the cluster. There's not much traffic going through it.
Yep.
So I imagine very low specs. You know what I mean? Like, literally. Now, the question becomes valid if I have 200 worker nodes. Can 4 CPU leader handle it? That's a good question. If anybody in the room here and the meeting knows the answer with credible, tangible data, not gut feeling like I'm talking right now, I'm willing to listen. So, but all I can tell you is that the leader node does not process traffic, and it's just like Splunk Cluster Master, by the way, if you're a Splunk customer, it's barely used, barely. So it is always safe to assume if you have the leader node the same specs as your worker nodes, you're good to go. That's an assumption, but I don't have hardcore data to back it up.
All right. Yep. I was just curious.
Yep. If anybody have anything to add to that one? Yeah. Oh, I'm just reading the challenge accepted from Eugene. Okay, we're going to leave this free form. Guys, questions, concerns, any comments you hear from other people? Do you find this helpful? Is it too much data or too little data? I really find it very helpful when you have multiple groups doing something like this. Normally I used to do it with a calculator. Now I just do it manually. I mean, not manually, but in the spreadsheet. Also, I found the disk space common question get asked. The tables, it's not so much of that because people don't even know ahead of time what they want, But also the horizontal scaling, when people have a higher specs here, this is a condition I caught at least one time with the customer. Like, whoa, wait a minute, we will have more traffic than you can handle. So the table also comes handy. This really comes handy because a lot of times customers don't just have 30% drop one destination. They have multiple things. One destination you get 100, the other one get 30%, and possibly the larger the customer, the more this automation you see here becomes handy, the more these questions you get. So questions. Actually, I'm going to stop sharing and see everybody's face.
You're a mad scientist with spreadsheets. That I do know.
It's more than I wanted to learn. Yeah.
Awesome. I mean, if anybody has any feedback or comments in terms of, improving it, changing it.
We have all this brain power here, and everybody's shy. They're like,
feel free to share. And then also any questions in general, any other directions we want to go. We've got a good 20 minutes left.
Does your calculations go into effect if you're streaming out different data types, like if you're pumping out JSON or like metrics versus, just a standard Splunk format?
Yeah, the or cardinality, that's another factor, or the number of projects you have. Unfortunately, I don't have a scientific way of approaching this thing, and I think it'll be a difficult subject to tackle too. The question becomes, how complex can my regex become before your specs doesn't, work? This becomes a real world deployment issue. So the numbers we published, it's buffering. It's assuming certain assumption in a lab environment with certain number of regexes. And by the way, we have a profiler in the product. So I don't know if you're familiar with it, but you can go to the profiler and look at your regexes impact and each line impact and the type of file impact. So that data you can get it, but to put it in a repeatable format where we can say, oh, I'm going to plug in those numbers and get that specs. I don't know if it's there yet. I don't even know if it's possible, if you ask me.
Oh, so I ran into this quite a bit. So this is the kind of thing where it's been really detailed, very granular CPU metrics in order to track this kind of. It's because you can profile each one of your changes, but then adding up each one of your changes over and over again to come it's very difficult to do. So that's why we had to have detailed. I used another tool to do the CPU monitoring outside of the monitoring console because I needed something that was going to be a lot more granular and much more detail oriented.
Okay. There you go. Here's some answer. But any other questions, feedbacks? Eugene always have a question. Eugene?
Yeah, I've been answering some of them in the background, and I think I mean I've been talking to Ed before about the issue that we have of the syslog data coming in from a single source, which is kind of what he was alluding to with his question about having a load balancer, because having a load balancer split up traffic from a single source into multiple, where you spread it out evenly, it can sometimes be challenging depending on what load balancer you're using.
No, I always think of F5s, but yeah.
Well, so apparently that's an issue we ran into, is with UDP, Datagram LB has limitations when it tries to spread it evenly.
Yep. And it's even when you say even distribution, the load balancer will do it by event count. Sometimes events are bigger than the others. So technically, you're getting more bytes for this event and less bytes for that event. So yes.
Yeah. What we ended up doing is actually standing up a buffer worker group that's receiving all the UDP events, and all it's doing is sending it on to other groups for processing over TCP/JSON with a persistent queue on those buffer worker groups. So the spikes are localized to that buffer worker group where it's not doing much, so it can handle more traffic, and downstream worker groups are handling the actual work. And if they are backed up, then builds up the persistent queue. So it helps, we did manage those spikes.
It takes the connection overhead off of your transformation worker groups.
Yep.
But I have seen some customers try to especially use TCP syslog instead of UDP, and trying to load balance high volume TCP syslog is very difficult.
Yeah, that didn't seem to work at all. It wasn't splitting the traffic up at all. So.
It's too much of a stream. It's looking for a break in the traffic, and when there's no break in the traffic, it can't do it.
Yeah, actually, even network devices. I remember many moons ago, Cisco, not ASA, PIX, even ASA early days. You turn out PCP login in a high volume box and just crashes. I'm sure they fixed it now, but every time I hear syslogin, I always assume default UDP. Yes, you can do TCP, but
like
so
Fortinet
legacy systems
TCP a lot. Yeah. That's just very difficult to be able to spread that out.
Yep. Anybody seen any interesting stories to share from in their own environment, customer or something like that? We have to kill another 45 minutes, otherwise it's up to you guys.
Hey, Eugene, would ask you, so did you consider maybe using your as a routing mechanism as well? So you could route, for example, with tags, you could route to stage for if you wanted to in terms of your log onboarding process. Use it as a brokering mechanism, not just for the syslog connection overhead, but for other things too.
Haven't really had the need to do that at this stage. The main thing I'm just doing is using an output router to spread between the workers in the worker group that's doing the real work, but that's about it. Okay. And with the buffer worker group, because there are basically two servers in each worker group for that if F5 can't spread the load, at least it's sending it to one, and we're effectively in HA configuration rather than load balanced. But since the box is not doing much, it can handle it.
John, you always have a question, man. Why are you so silent? That's how you get him to go off mute. Oh, he went back to mute. John?
Can you hear me now?
Yeah, we can hear you loud and clear.
Oh, yeah. I'm just listening in.
Really? You went off mute to tell me you're listening. I want you to say something. Anyway.
Anyway, guys. The syslog issue is huge. I don't know how we solve that, but that continually comes up, and we've got to come up with a workaround for that at some point.
Okay. All right. Thank you, guys. Appreciate your time. And you can turn off the recording now, Shane.
Yeah.
Have a good one.
And just so everybody knows, the 17th, we've got Brendan on. He's going to do AWS data onboarding and enrichment. That'll be our next Cribl office hours in 2 weeks. Same time, same channel. But thank you for joining today.